All right, so welcome to the video lecture series on Introduction to Computer Networks. This is part 6 of our lecture on the topic of the Internet Protocol and the last part of this particular topic. So we'll jump to the point from where we left off and we will start talking about IP routing. So we know that the network layer is responsible for sending and routing packets from a source to a destination across multiple networks. In this process, a packet may actually go across more than one network, and there is a process of decision which needs to be resolved as the packet is transferred from one network to another. So for this, the routers have something that we call a routing table based on which they make the forwarding decisions. So the basic idea is simple. If the destination IP of the packet is in the same network, the packet is forwarded directly to the host. So the router already knows where that particular host is because it is in the same network. However, if the destination IP has a different network ID, that is, the destination is not within the same network as the source, the packet is forwarded to the default gateway. And here, the default gateway is something that we say is the fixed default destination that is set for every host if the destination is unknown. And the IP address of the interface on the router is it's connected to the host network. And by default, whenever a host would try to send a packet to outside of the network, it would use the default gateway. So let's say for this example, we have a host here with an IP address of 192.168.1.5, and it has a specified default gateway of 192.168.1.1. And if we look at the diagram, the router right here has the default IP address 192.168.1.1, and this is the IP address that is set to the interface on the inside. That means that this host right here and this interface of the router should be part of the same network ID. So therefore, when a host tries to send a packet which is not in the 192.168.1 network ID, it would then send it to the default gateway, that is 192.168.1.1. The router receives the packet and then forwards it on to the outside network. So the way routers populate the routing tables is can be both static and dynamic. So it is something that is used by routers to is absolutely required by routers to make forwarding decision for every packet, right? And they are stored and maintained by the routers. And entries in the routing table basically include two things. The first is the network ID, and and along with it is paired the port or the interface that is connected to that particular network ID. So routers can learn routes based on a static configuration where the network administrator enters the networks to which the router is connected and the ports to which these networks are connected. And whenever there is something something changes, the network administrator needs to modify these records manually on each of these routers. However, there is also something that we call the dynamic configuration, and in this case, the routers they are able to learn the routes from other routers which are connected to it. And this is facilitated through different routing protocols. And these routing protocols include different methods and information which allow the routers to share their routing tables with one another so that they are well aware that which network is located in which part of the larger network, and they basically keep on sharing their routing tables and keep on updating their records in a dynamic fashion. The common dynamic protocols are RIP and OSPF. We will not look into the details of these protocols. However, just it's important to know that these are the two common protocols which allow routers to learn the routes dynamically. So we'll look at a simple example how packets are routed across multiple networks. So let's say host A would like to send a packet to host B. So host A creates the packet with the destination set to 10.0.0.5, which is the IP address of the host of the destination host. And then it sees that the destination IP is not a part of the current network ID. The current network ID is 192.168.5.0/24. However, the destination IP of the packet is 10.0.0.5. So once it sees that, it knows that it needs to forward it to the default gateway. The default gateway here is the interface that is connected to host A's network on the router, which is FA0/0. So once the router receives this packet, it first checks the destination host IP and it calculates the destination network ID from the host IP, and it sees that this belongs to the network ID 10.0.0.0. It then looks into the routing table and sees that there is an entry for that particular network ID, which is probably the network where this destination host is connected, right? So the router now transfers the packet from interface FA0/0 to the other interface, FA0/1, and forwards the packet to the other network that it is connected to. And eventually the destination then receives the packet. So if we look at a much larger scenario, not the simplest case, probably still much simpler than any other network, we can consider a scenario where there are 3 networks which are connected through a single router R1. So R1 has a default gateway address connected to each of these networks. So let's say if PC31 over here would like to send a packet to the IP address 172.16.1.99, it sees that this does not belong to the same network ID, which is with the prefix 172.16.3. So now, instead of trying to find the destination within the same network, it forwards the packet to the default gateway. The default gateway considers or consults its routing table and then finds that the network with the prefix 172.16.1 is connected to the interface FA0/0. So it forwards the packet to that interface and to that particular host. In a different scenario, let's say PC22 would now like to send a packet to the IP address 172.16.2.21. So the host checks the IP address and sees that the destination IP address is the same as its own network. So instead of sending it to the default gateway, it sends it directly to the host, which it can reach just because of the fact that it is a part of the same network. So we have seen that the IP or the Internet Protocol is the predominant protocol, the primary protocol of the Internet Hourglass model, and also the main protocol in the network layer in the TCP/IP model. So this is the primary protocol that is used to build the TCP/IP network. However, there are a few other protocols which are a part of this layer 3, that is the network layer. However, all of these protocols actually support the functionality of the IP or work in conjunction with the IP protocol. The first one is ICMP, which stands for Internet Control Message Protocol. And this is a common protocol which is used by hosts and routers to manage and control the network. One very common example of ICMP is where you can send a ping echo to a host on the network and wait for an echo reply from that host. And this would mean that the host that you just pinged is alive on the network. So that's a common example of ICMP. So it allows you to exchange control messages between hosts and routers in the network. We have already looked at the ARP protocol, which we looked at in the data link layer. But this is a protocol which runs with information from layer 3, that is the IP layer, and runs in layer 2, which is the MAC layer. So it is used by LAN hosts to dynamically learn MAC addresses, however, using IP addresses of other hosts. One thing that should be noted for ARP is that they are only able to learn the MAC addresses which are on the same LAN. So it doesn't cross the network boundary. It only allows you to run within the same network. The next protocol is DHCP, Dynamic Host Configuration Protocol. This is a common protocol which is run on a server and allows different hosts to be assigned IP addresses whenever they're connected to a LAN. So the basic idea is that you have a DHCP server running on a network, and whenever a new host connects to the network, it requests the DHCP server for an IP address, and the DHCP server assigns an IP address for that host to use as long as it is connected. Right at the moment it is disconnected, it actually releases it, and then it can actually reuse it later for another host. The next protocol is DNS, the domain name system. This is again kind of a server, a DNS server, which allows you to translate IP addresses with host names to IP addresses. And the best example is where you are actually browsing the internet. So let's say if you type in www.google.com, google.com is basically a host name, right? It doesn't imply an address specifically, because we have already seen that there is nothing that we can use for addressing which is in the form of characters or names. So the DNS system, the domain name system server, allows you to translate google.com into an IP address to which then you connect to and receive the web page from. So the DNS server is a global and worldwide server system with multiple tiers, and we will look at it a bit more in details in the internet chapter on the topic of the internet. And this is another protocol which runs in conjunction with the IP protocol. And finally, we already mentioned the RIP and the OSPF protocols, which are dynamic routing protocols, and it allows routers to learn IP routing information and share IP routing tables between the different routers so that they can populate their records better.